Good morning. Welcome to Purdue's Security Seminar. It's my great pleasure to introduce today's speaker, Dr. Marianne Winslett. She has been a professor at University of Illinois at Urbana-Champaign since 1987. Her current research interests include security in open systems and data management for high-performance parallel scientific applications. She was an editor for ACM Transactions on Database System from 1994 to 2004 and has been the vice chair of ACM SIGMOD since 2000. She received an NSF Presidential Young Investigator Award in 1989.
Great, thanks, Mingwei. Well, today I'll be talking about what we have found out about using trust negotiation in real-world settings. And this is work I'm doing with two students, Adam Lee and Charles Zhang, and also with some collaborators at other universities or other organizations. Jim Basney and Vaughn Welch work at the National Center for Supercomputing Applications, and they're associated with the grid security infrastructure. And also, I'm working with Piero Bonatti at the University of Naples and Wolfgang Neidl at the University of Hannover in Germany. So I realized that there are professors and students who do research on trust negotiation here. And in fact, I know that several seminar speakers in this seminar have talked about trust negotiation. So I didn't want to do a super long introduction about it, but not everybody may have seen the previous seminar, so I thought I'd do a little bit of a condensed intro. So trust negotiation is an approach to authorization that's for use in open systems. And by an open system, I mean a system where resources are accessed across organizational boundaries. And here's an example of how that might look. Suppose that Alice is an employee of Widget Corp. And normally she's based in California, but she takes a business trip to Widget Corp's office that's in Beijing. And then when she gets there, she needs to plug in and access local information and local data. Well, not just anyone can log on to the company's network. They have admission control. They check to see who she is before they allow her on. So before she can get on the network, she has to prove to the network that she is trustworthy. Usually that's done by typing in a login name and a password. And if she has this login name and password, that allows her to prove to the network that she's trustworthy. But there's no trust in the opposite direction. I mean, why should Alice trust this network? Does it have the latest patches? Are they running virus protection software? The trust is entirely unidirectional, and that's maybe a little bit scary. And then the next thing that's not very pleasant is that when Alice tries to log in, her identity isn't known by the local network's authorization server because she comes from a branch office far away. So she can't actually get on the network, even though in theory we know that it should be okay because she is an employee of Widget Corp. So there are various ways that we could solve this problem. For example, the Beijing office could in real time check back with the office in California and see if Alice is a legitimate employee, or maybe we could have some sort of distributed identity-based solution. But I think what will be more scalable for the long term and a lot easier to manage is if we base the access rights of Alice on the attributes that she can prove about herself and not on her identity at all. In this case, what's relevant is that she's an employee of Widget Corp, and that should be enough to get her initial access to the local network. So let's see how that might work. The Beijing office, maybe it's not going to let people from other branches of the company access every subnet of the network. Some things may be a little sensitive and private to the local office, but at least for very basic access, anybody who can prove they're Widget Corp employee should be allowed to get on the network. So Alice can prove this by showing that she's an employee, maybe some sort of digital employee ID, but then she may have her own restrictions. she may not be willing to present it to network authorization servers that don't have a certain patch levels, for example, patch level 4 or higher. So she may want the authorization server to prove some things about the network before she shows it her credentials. So the problem here is that on the Beijing side, the network manager has to know how to specify and enforce the local office's restrictions on resource access and usage. And Alice has to find out about Beijing's policies and somehow satisfy them while she's still enforcing her own access policies. Well, how do we solve this problem? Two pieces of the puzzle are, first, having a policy for every resource that Alice might try to access. that an outsider might try to access in this network. And for every resource Alice has that she might be willing to show to an outsider, such as this Beijing network authorization server. So that's the attribute-based access control policies piece of the puzzle. And another piece is trust negotiation, which is runtime software that will clients and servers can use to show that they satisfy each other's relevant access control policies. So let's look at an example of how this might work in this particular case. On the left-hand side of the screen, we have Alice's security agent, and it's running this TrustBuilder software that I'll be demonstrating to you later on today. And we've got some icons on the screen. That handshake is a TrustBuilder logo, and down below it we have a little picture of a TrustBuilder agent that I'll talk about later. And this security agent has access to various credentials that Alice owns and policies about who she's willing to show these credentials to. So if this is her employee ID, it looks like the access control policy that protects it is that she'll only show it to servers that have patch level 4 or higher. Similarly, on the Office Network Authorization Server side, they've also got a security agent. And this policy here says that if you want to get access to the network, you need to show that you are an employee of the company. And it has a digital certificate that shows it has patch level 4. Okay. So at runtime, the way this would work is that first, Alice tries to access the LAN. The authorization server gets her request and sends back the access policy for accessing the network. And that says that on-site access is allowed, but only for widget core employees. Next, Alice says, well, if you want to see my widget core employee ID, then you have to prove that you have patch level 4 or higher. And the network authorization server is willing to show that to anybody, so it sends it back to Alice and proves that it owns it by signing a challenge. Next, Alice is willing to disclose her employee ID because the policy for access to the employee ID has been satisfied. So she sends it to the other side and does a proof that she owns it. And then finally, the authorization server lets her access certain subnets of the LAN, whatever that particular type of user is entitled to see. Okay, so this is... Things to note about this are that first, it's an automated process. Second, it's iterative. The two parties slowly built up trust, starting with innocuous little things like I'm patch level 4 and working up to more sensitive information like I work for widget core. And it's bilateral. Each party got a chance to have its own requirements for trust fulfilled. So it's bilateral. Another thing that we can do with these facilities is that we can renegotiate trust later on. So suppose that Alice accesses the local network for a while and then she wants to go to a particular subnet that has, say, financial data that not just anyone